On the first worksheet in section 8.7, question 6, we're asked to find a Taylor series for this function, x squared times e to the x. It's a pretty simple one, but it's one that we haven't done a whole lot of, so we're always going to start with what we know. This is also a little review. Don't forget e to the x from now on can always be represented, if you're talking about centering it at 0, as the sum from n equals 0 to infinity x to the n over n factorial. If you wanted to write out the first few terms, that's going to be a 1 plus an x squared over 2 factorial plus an x cubed over 3 factorial plus an x to the 4th over 4 factorial, and so on. I mention that because you've seen some of the later questions say take this series and solve it. So it doesn't hurt to be used to what the first few terms look like. It's all the powers of x and all the factorials. So if I want to know h of x is x squared e to the x, I can take my e to the x and replace it with the series. Yes, you could make a big old chart, but the chart is going to be horrible because your derivatives are going to be chain product rules and not fun. Instead, we can say that this is the same as x squared times the series from n equals 0 to infinity x to the n over n factorial. Now this just means this is an infinite series, right? Like up here. If I multiply that by x squared, that means multiply every term by x squared. The 1, the x squared. So we're going to multiply them all by x squared. So you might as well just multiply them inside the series. So this is the series from n equals 0 to infinity x to the n plus 2 over n factorial. That comes, remember, x to the n times x to the 2 is x to the n plus 2. That's all we're doing in that step. If it helps, we did that a couple of times in the video we just finished, so you can go back and look at that one instead. We can also do, while we're at it, number 7, which said find a Taylor series for capital H of x equals e to the negative x squared. This one, we're not multiplying e to the x. We've actually changed e to the x with substitution. So we start with what we know. E to the x is the sum from n equals 0 to infinity x to the n over n factorial. And a substitution says I'm going to take both x's and replace them with negative x squared. So parentheses can help you a lot. That means that we get e to the negative x squared equals the sum negative x squared to the n over n factorial. Now, you could stop here, but it's not really elegant. It's not really what you want to do, because we say a power series has the form coefficient times x to a power. And at the moment, our x is kind of tied up with this negative. So instead, we're going to distribute on the right side. This is the series, negative 1 to the n. It also helps to pull that out so you can immediately see it's alternating, which means estimation isn't hard. And x to the 2 raised to the n is x to the 2n over n factorial from n equals 0 to infinity. So I'm going to write this out so you see it, and it can help clear one thing up. If we write out the first few terms, this is going to be a 1 plus minus, because it's alternating, an x squared plus an x to the 4th over 2 factorial minus an x to the 6th over 3 factorial plus an x to the 8th over 4 factorial, and so on. Now, if I just show this series to you, you might think immediately cosine because there are even powers. That's why in class I've said it helps to think more of the factorials. I've got a 2 factorial and a 3 factorial and a 4 factorial. That's all the factorials. So this should make you think, aha, it's e to the x, not cosine. The factorials are harder to fix. Just like in the previous example, we can substitute for x all we want. The factorials, they're kind of stuck. So use those to gauge what we're looking at. So the answer to number 7 would be this series.